From Newton's laws of motion, we know that force equals mass times acceleration, in which the acceleration of an object caused by a force is equal to the force divided by the object's mass. How do we describe a rotating force, though? We can use torque. Torque is the measurement of the force that causes something to rotate. Not only in fidget spinners, torque is an underlying concept that appears in many places. Bob the Builder here is building a playground and needs to use torque to understand the physics of the playground equipment. When Bob sits on the seesaw, his weight causes it to rotate about its pivot counterclockwise. His weight is the force. Mathematically, the torque is equal to the force times the radius. The force refers to the force component perpendicular to the horizontal lever arm. If Bob pulls on the seesaw lever, the seesaw will not rotate because the force has no perpendicular component and only a parallel component. It's only the perpendicular force that counts. When Bob sits on the seesaw, Bob's mass, 100 kilograms, multiplied by the gravitational acceleration, which will round to 10 meters per second squared, produces a 1000 Newton force downward, perpendicular to the current lever's gradient. The radius is the distance from the point of the force's application, where Bob is sitting, to the pivot. Would Bob have more torque at point A or point B? The correct answer is point A. The torque at point A is 2000 Newton meters, while it's 1000 Newton meters for point B. By sitting double the distance from the pivot, Bob had created double the torque. Bob is bored of the seesaw and goes to the merry-go-round spinner. He brings his 5 kilograms cat.